get your packet out. So we skipped over the algebra ones in here. We've done these, but it's just been a while, so I want to review them. And then, so number 19 is where we're going to start. And then I made another packet for you and gave you answers, and I'm going to give you that packet and shut up and let you do it, so you can do some independently. Yeah, you can ask me questions. I just so that it's not like so teacher guided. 19 is where we're going. And then I'm going to hit you with another packet after that. It's kind of a combination of algebra and the graphing stuff. And we're going to have a test next week. Probably like, it might be a 2-day test. 1 day on graph stuff and 1 day on algebra stuff. So maybe like Wednesday, Thursday, or Thursday, Friday. Probably Wednesday, Thursday. Wait, what? We left school Monday. I know that.
It's at Harvard Prep.
Okay, so number 19. Similar idea to the graphic and stuff. We're just looking for relative max. We want to know when the original function switches from increasing to decreasing. Which means we want to know when the derivative switches from positive to negative. And you guys did this when we did like the, here's an equation, do all this crap and then graph it. So we're just kind of piecing together, review a little bit. So you find critical points first, so you take the derivative. And I'm starting with the derivative because what level do relative maxes come from? The first derivative tells me relative max, relative min, increasing, decreasing. So that's why I'm doing that first. Set that equal to 0. If there were a bottom, I would set that equal to 0 also. And then solve. So what can I factor out of both of those? 3x. So this will give me x equals 0. This will give me x equals 2. And then if you remember making those number lines, 0 and 2 on there. Actually, I'm sorry. That's like that stuff at the end. We more split it into intervals. Like negative infinity 0, 0 to 2 to infinity. It's the same idea. Just writing it out differently. And then I want to pick a point from here and plug into the derivative. Because if the derivative is positive, what does that tell me about the original? Increasing, positive slope. If the derivative is negative, what does that tell me about the original? Negative slope, so decreasing. So I'm plugging into the derivative. And plug into whichever one of these two forms makes your life easier. So, so let's say negative 5. Well, this is just two things being multiplied. So if I plug negative 5 into that thing, it's negative. If I plug negative 5 into that thing, it's negative. So that f prime is positive, which means f is increasing. So the derivative graph is above the axis here. The original graph is a positive slope. Let's say x equals 1. Plug it into that thing. Positive. Plug it into that thing. Negative. F prime is negative. So therefore f is decreasing. You're worried about Rod's location instead of the decreasing, increasing.
Yeah.
You probably just went to the line.
Hope he doesn't have COVID.
It's probably going on. Then if I plug, hey, look what you did, Lucian.
Yeah, man.
And then if I plug in like 5, that'll be positive, and that'll be positive. So f prime is positive, which means f is increasing. And I want to know where there's a relative max. So I want x equals 0 because that's where you can say it either way, because the derivative switches from positive to negative. So if I were looking at a graph, the derivative graph would go like that. Or the original switches from increasing to decreasing. But that'd be at x equals 0. Questions on that one? And you will get a chance to do these. I'm just running through a few algebraically with you to remind you how they work. 19, okay? Stop cussing at me, though. Because the f prime is positive. If the derivative is positive, that means the slope of the original is positive, so the original is increasing. You with me? Yeah. Good? Any other question on 19? Alright, 20. What level do I get information about inflection points from? Second derivative. So that's my original. Y prime would be bring that down, reduce the power by 1, multiply by the derivative of the inside. And like typically there's no real reason to simplify. But I don't have to do any work with the first derivative. I do have to take the derivative of it. So I think it is beneficial to simplify. And I'll just say, okay, 1/3 times 3 is 1. And then my derivative is this. Take the derivative of that. Bring down the -2/3. Leave the inside alone. Reduce the power by 1. Multiply by the derivative of the inside. Now we need to set the top and bottom equal to 0 of the fraction, so we need to make this into a fraction. So these 3's are going to cancel. We have a -2 on top. And 3x minus 15 to the 5/3 on the bottom. With me so far? Remember how to take derivatives, multiply, stuff. So let's set the top equal to 0. What will happen? -2 equals 0 never happens. Not 0. It's never. Careful there. 3x minus 15 to the 5/3 equals 0. So remember what we could technically do is raise both sides to the 3/5. And then 0 to the 3/5 is still 0, but the shortcut is just you don't need to worry about the power. And I will get x equals 5. Am I positive that that's an inflection point at this point? I'm not. It's a potential inflection point. It probably is. But it could be that I'm concave up before it and concave up after it. Like things don't have to happen there. They just usually do. So I gotta check. -infinity to 5. 5 to infinity. So let's say I plug in like 0. What level am I plugging into? Second derivative. Why? What am I looking for? Concavity. I'm trying to find information about inflection points, right? I want to find the conc up and conc down to see if it switches so I can say, yes, that's an inflection point. So I'm plugging 0. 0 minus 15 is a negative number. What's the third root of a negative number? Still negative. And then a negative number to the 5th power. Still negative. So f double prime is negative. Which means what is true about f? Oh, yeah. Oh, that's negative divided by that, isn't it? So I have to say, thank you. So f double prime is positive, which means what's true about f? F is concave up. And then if I plug in like 10, 30 minus 15 is a positive number. What's the third root of a positive number? Positive. Positive number to the 5th power. Positive. And then a negative divided by a positive. So the second derivative is negative. And the f is concave down. So is that an inflection point?
Yeah.
Yes, it is. Question on that one. You guys want to try 21? Remember quotient rule?
Maybe. Really don't.
Everyone knows quotient rule. Remember, you got the bottom times the derivative of the top minus top times the derivative of the bottom. I got my derivative up there if you want to check that. I haven't got beyond that yet, but.
Ah.
Just wanted to practice more, take the test up more.
So I'm practicing that.
I factored out a negative 2x. And then that leaves me with x plus 4 on the inside. Alright. Should have 3 critical points. 0, negative 4, and negative 2. It's not the appropriate time to discuss my weekend. But. So our next step is, what's your favorite movie? Yeah.
So I did the quotient rule.
Yeah. Did you get what I got?
Yeah, right there. What are you doing?
Set the top equal to 0.
Okay.
Solve it. Set the bottom equal to 0. Solve it.
Okay, so that's how you. Okay.
That's how I got those numbers. Yeah.
What?
So here's your derivative. So the top equal to 0. Make sure you factor and don't like move things to other sides, because if you added 8x to both sides and cancel an x, you're canceling out the answer of x equals 0. So at the bottom equals 0, you get this. So I got my intervals. And then I plug in a point. I'm looking for a relative min. So mins come from the derivative. So I plug in a point in each of these intervals into the derivative. I believe you get deke, ink, ink, deke.
Indeed.
So the relative min would happen when we go from deke to ink. So there's a relative min at x equals -4. Questions on that one anywhere? Can I talk through any steps here? Alright, 2 more I want to do with you, and then we're done with this packet. You guys will do one on your own. So we're going to go to 21, or 22, I mean. This is mostly to remind you of what rule? Product rule.
Let's go. It's your boy.
Plus chain. Although there's not, the chain doesn't really matter in this one. But yes, chain. So 2d1 plus 1d2, right? So the second thing times the derivative of the first thing. So yeah, so the derivative of the first thing is chain rule. So you bring down the 5, leave the x plus 2 alone, reduce the power by 1, and then multiply by the derivative of the inside. But in this case, what's the derivative of the inside?
1.
Just 1. Plus first thing times the derivative of the second thing. So that's chain rule again. So bring down the 4, leave the x minus 3 alone, reduce the power by 1, multiply by the derivative of the inside, which is 1. And then this is why we have, so critical points, we're just basically saying how many times does the derivative equal 0. So we're trying to set that up. I'm not even asking you to solve it, I'm just trying to figure out how many times it happens. So this is why we had you practice getting things into one term. So this is where we're going to factor out chunks, like that reverse distributive property thing. So how many x minus 3's can I pull out in front? 3 of them.
Oh, I remember.
How many x plus 2's? 4. And then if I did that to this term, I would still have an x plus 3, or I'm sorry, an x minus 3. I still have an x minus 3 remaining. And I'd still have the 5 remaining. And everything else would cancel out. And if I did that to this term, the x minus 3's would cancel. There'd be a 4 remaining, and there'd be 1 of the x plus 2. So our job is just to figure out how many critical points there are. You might be able to tell now. You might need to keep going. I don't know. So if I solve that, how many answers am I going to get? Like, we're going to set this equal to 0 at the end, right? So if I solve this, I'm just going to get x equals 3. I don't even really care what the answer is in this case. I just care that it's one answer. Here I'm going to get x equals negative 2. And then here, I'm going to have 5x minus 15 plus 4x plus 8 equal to 0. Well, if I solve that, there's only one level of x, which is 9x minus 7 equals 0. So if I solve that, how many answers am I going to get? I'm just going to get one. So it is 7 9ths if we figure it out, but I don't really even care about that. That's what I meant, like you could tell maybe from here. So there's just an x there, so that's one answer, and one more answer. So there are 3 critical points. This is what they would be. You didn't necessarily have to go that far. But more to the point, I was just trying to remind you of, like, product rule. And then there's only one question we haven't done in this whole packet, and that is number 30. I would like you to try number 30. Be very careful when you read the question. It comes after 29 and before 31.
No, you gotta keep scrolling.
That'd be really hard.
Well, yeah, because look. You put like a bunch of questions right in the middle. Here, look. Here's,
Oh, they don't put order, do they? It's like almost
here's
the back.
27.
You're right. Okay, I'm sorry.
29, 31, 2.
I retract my smart ass comment. I apologize. It's almost in the back. It's too late. Which of the following are points? Find the points for question. So hopefully you noticed this, but what level were you given? Second derivative. So don't take 2 derivatives of that,
That would be.
because you're already at the second derivative. I don't know what the fourth one's called. Yeah, it's called the fourth derivative. Those are possible inflection points. Check them. Check them. You fell for it.
Yeah, I did. I got pranked.
You did it.
Dang it. What? Hey,
so first of all, they give you the second derivative. They ask you about points of inflection. So we're already at the level we need to be at. So don't take two derivatives of that. We gotta set this equal to 0, or each of these three chunks equal to 0, and solve, so we get 0, 2, and 4. These are my intervals I built around them. They're trying to get you to see 0, 2, and 4 as we're in second derivative equals 0, and just circle B. But if you check them, I'm pretty sure that they're not all. So if I plug in like -1, that part's positive, negative, negative. So what's a positive times a negative times a negative? So F double prime is positive, which means F is concave up. If I plug in 1, we get positive, negative, negative, right? Yeah, so this is still concave up, so it's 0 point of inflection. It's not. If I plug in 3, I get positive, positive, negative. Now it's 2 a point of inflection. It is, we change, and then at 5, I get positive, positive, positive. So 2 and 4 are points of inflection, but you've got to know that 0 is not, and you only know that by checking. Questions on that one? Okay, so answers on the back here. There's 4 that you're skipping. So you might want to cross off those right away on the back part. And then I want you to be able to do it without me jabbering every 5 minutes, so you can know if you know it or not. What's that, Jess? Probably Wednesday, Thursday next week.
I'll be good.
Wednesday and Thursday of next week.
Oh,
I'm thinking like a 2-day test.
Oh, wait. This is next week.
Yeah,
Oh, I thought this was. Wait.
this next week.
Oh, wait a second.
So you're skipping, if you look on the back, 4, 11, 12, and 15. 4, 11, 12, 15. And there, like if you go check the answers, you'll see a dash there and then you get the answer. Four, 11, 12, 15.
Oh, whoops.
And so I'd like to give you today and tomorrow to work on this. It's not as bad as it seems. Some of the graphs they make, like you look at this one, they make the options, like, this is a full page. This is like option D. This is option B. So like some of the questions are like 5 pages. Stupid.
Wait, how come
Not as bad as
question 2 literally doesn't have it? Because it's very response graph.
Wait, what?
But there's a letter on that graph. I'll just draw it. What? Let me see. Jack, let me see. Graph. Twice different.
Oh my god, I didn't print the whole thing. Just give that back to me. That's, you have to put it in their cycle, it's useless.